Hello, all. This is Matthew, and today I thought that I would do a quick. Well, I'll just put it this way. This is going to be a quick video, hopefully kind of quick video on basic multimeter use, and it's going to be a part of a video series on using things like multimeters and oscilloscopes and electronics design and stuff that I'll be having on my website. Website's not really done right now. It looks like, I don't know, a nerd invaded a yoga studio because of I'm using I, I'm I haven't built the website really yet, but anyways, this is going to be one of the first videos in that series is using just a multimeter for basic testing. Multimeters are also known as multi-testers. Same thing pretty much. I'm going to be using this cheapy multi this manually ranging multimeter. And I'm doing that because I think more people are going to have the multi-ranging cheap multimeter than they are going to have the nice, you know, auto ranging multimeter. That, and it's good to get used to using manual ranges on when you're using your multimeter, even if it does automatically find ranges, because if you start to get to where you're doing a lot of testing, well, there's two reasons why I always say that it's good to know how to use manual ranges on multimeters. The first is that when you're using a multimeter, you should really be thinking of things in the same way that you would if you were a scientist. You want to be expecting a result and then confirming or uh, revising that idea based on the results of your tool. So if you don't really generally speaking, if you don't really have a general idea of what range your result is going to be in, then you're probably not really thinking of your circuit very well, or you're just kind of doing some very basic information gathering. Look, let's check some voltage here, let's check some voltage there. But most of the time, you really should look at your tool, your measurement tool, as a means of confirming a hypothesis. And if you do that, not only will you troubleshoot more efficiently, you'll also learn more. Um, because when you expect a result and it's wildly different, that sticks with you very well. So I always recommend people do that for the learning aspect of it. The other thing is that if you test a lot of, if you are going to be doing lots of testing on a very complex circuit, and say a motherboard where there's a lot of different sections, if you understand that, if you know that your voltage, say in the motherboard example, is not going to be over 12 volts because that's the maximum voltage that the power supply puts out, you may choose to put your multimeter in a range that supports 12 volts like this. I'm changing it with my range switch. I'm going down and say, okay, well, this will support 12 volts. Then your multimeter doesn't need to cycle through ranges to find the 12 volt range and then say that that is a good range. Instead, we'll just use a 9-volt battery as a tester here. You see, I've selected a range that should give a decent resolution while still accepting this voltage. And the results are pretty much instant. They'll climb up a little bit, and that's just because the meter wants to average the samples from 0 volts to 10 volts. But it's not having to do that and go through multi-millivolts range and all of that. Especially if you're doing like voltages that are a little bit higher, like you would if you were working on some solid state amplifiers or something like that. If you know that all of your voltage is going to be over 50 volts, then you're skipping many ranges that this will have to cycle through. So like if we do this now with it in automatic ranging mode, you can see it'll go through multiple ranges and then it'll land on the thing. Luckily, this meter samples at the same time as it goes through the ranges, but a lot of cheaper meters don't do that. So it will fly through the ranges, land on a range it thinks it's okay, and then it will take its samples, and then each measurement will be slow. So keep that in mind if you have a fancier meter, but for now, let's just get right into it. So I'm going to cover the things that most multimeters support, the cheap ones and what you use the most, and then a little bit about capacitance, but that one, like for instance, this meter doesn't have a capacitance range, and it's kind of like that thing that you have meters that support it. Lots and lots of meters support capacitance. See, this one does here. That's what that little symbol is. But it's not necessarily very useful um, in many cases, because just a capacitance meter is kind of lacking. You want to be able to measure things like equivalent series resistance on in your circuit. And that's something that most multimeters can't do, not unless you get to very expensive multimeters. So yeah, so I'll be doing voltage, amperage, continuity testing, and diode, kind of slash diode testing, but diode testing. And then measuring resistance, and that, or your ohms range. And this will basically, sometimes meters will just show the little ohm symbol or say ohms, like we've got on our multimeter over here. And often, or it'll say just resistance, but it's the same thing. All right, so first off, let's get started with voltage. So um, most multimeters support, well, pretty much all multimeters support both AC voltage and DC voltage measurements. I've got this or this because I'm doing that to represent a positive voltage and a negative voltage, and we'll get into that a little bit. But if you want to understand voltage more, I highly suggest that you check out the excellent video on voltage from um, Afro Tech Mods on YouTube. He's brilliant, this guy, and he's an incredibly good speaker, and he really puts a lot of effort into his videos, you can see. So yeah, I recommend that you look at that if you want to understand more about voltage. But so yeah, it'll measure both AC and DC volts. Um, just a quick rundown of what AC voltage is and DC voltage. AC voltage, or AC, well, basically it's AC, alternating current versus direct current, and current and voltage and all of that. All relates together through Ohm's law. So if you spend some time learning Ohm's law, you'll understand this a bit better. But alternating current is um, basically going to be current or voltage that is that has a changing polarity. So say you start measuring something, and the red probe, it measures things above the 0 volt cross line here. So it would be measuring this part and saying that it got up to 1 volt. There would come a point where it would then cross this 0 volt threshold and then start to look like a negative voltage, because now the positive has moved over to the black lead and the negative has moved over to the red lead. So what you're really seeing is this flip-flop, and it's just most convenient to measure it like this, or to draw it like this, like a sine wave, because that's what it is. So that's alternating current, and then direct current is just saying that the red lead is measuring, say, 1 volt, and then the black lead is measuring the 0 volts, or you've got the red lead happens to be on the 0 crossing mark, and the black lead is even lower than that. So you end up having a negative voltage there. So yeah, so that's kind of a quick explanation of AC versus DC, but again, it's really a very good subject all on its own. So do check out Afrotech Mod's video on that. So why would you need to check voltage? Well, there's a lot of reasons, and when it comes down to it, pretty much all measurements you take on a multimeter will measure either voltage or amperage or both, and then derive the rest of the results from that. So it's kind of voltage is kind of that one of those main important ones. But for what you'll use it mostly on is you will check voltages of your voltage supply, and you will check your use it for voltages to see how many volts have dropped before and after a component. And then you'll be able to tell a great deal about your circuit that way. So um, most of the stuff that you'll be doing as a hobbyist is probably going to be direct current. That's pretty much what all of your common circuits are used for, or are using. They're always going to pretty much use direct current. Even if you get AC out of a wall and then do it into a circuit, unless you're doing some interesting things like you're doing stuff with vacuum tubes or something like that, then you're probably going to be changing that AC into DC and then running off of DC. So um, AC, AC and DC are normally um, your AC and DC ranges are normally marked and displayed by these two symbols. Let's see if I can get this in here, and let's see if it autofocuses. Actually, that's right. I disabled autofocus because it was not working. It did not like it. I don't know why, but so we'll go in here. So you'll see that you see the white little squiggle. That's representing that sine wave, and that's your AC voltage range. And then DC is normally denoted with a line with one or two or with two or three dashes below it. So yeah, so if you see this kind of layout, what this is saying most of the time, if you see like how you see how the letters like V and 10A and MA and those are white, and so is the AC, and then the select is orange, and so is the DC. Normally that means that you're going to default on your multimeter to AC, or a lot of multimeters default to DC because that's more useful for hobbyists. This multimeter is really meant for measuring like mains voltage, things for like HVAC people and things like that. So yeah, let's bring that back down. Um, but you'll notice on this meter, you've got a couple of different ranges. It's different. You've got sections, and each section does a different thing. So you've got this V, you see you've got two V's for volts, but then underneath you'll see this one. Oh, maybe it's going to be pretty hard to see on this camera, but this one is the one with the DC symbol on it, with the one line with the three dashes below it. And then this little range here, this is the one that has the AC on it. So um, let's measure some voltage. So on a manual ranging meter like this, you'll notice it's got different ranges going up and down here. So this is on the DC range. If we go all the way to the very bottom, it says 200 M. And what that's saying is that your circuit should have no more than 200 millivolts to use this range. And this 2 means it should have if we go to 2, it means you should have no more than 2 volts to use this range. Now the reason why this is important is because if you're way down here on the 200 millivolt range and you go to measure say 300 volts DC, then you will be sending way too much power to the chip inside your multimeter. And most multimeters, well-designed ones, are going to be able to withstand that for a few seconds. But that's a huge discrepancy there. So you want to start higher and move lower. So say that you knew that your circuit would be in some range, and it will say that you knew that your circuit was going to be somewhere between 75 volts and 5 volts. We'll go all over the place with that. But say that you know that. You want to start off with the range that is going to be able to handle that. So we'll say it's less than 200 volts. It's not going to go more than 75 volts. I should be good. And it will display the right voltage up here, but without as much clarity if it turns out to be a low voltage like 5 volts. And I'll show you that with this demonstration. So let me bring in this breadboard, and let me grab a box here and just get this up here nice and close so that you guys will be able to see what's going on. And let's adjust that focus. Okay, so if you don't know what a breadboard is, a breadboard is just a board of sockets, um, and the sockets are arranged in a very specific manner. And I've kind of drawn on this one with some Sharpie to help explain this, but you'll see, you see how they've got the blue and then the red here? Those are bus bars. It's basically saying that all of these sockets on this range, so on this row, are all connected, and that's why I've got this drawn like this. And you can see that this is one row, and then this is a separate row that isn't connected to this one in any way. But then all of these sockets are connected this direction. Then when you get in the middle, you've got all of these other little rows, but they are only connected in sets of 5. So these 5 sockets are connected this direction. These 5 are the same, just like that, and it keeps going like that. And what this does is it lets you make a power rail across these bars and then build off circuits off of that rail. So you can see, like, I've got a little circuit here, and let me adjust something, guys. Let me adjust the brightness on this camera. Let's do this, and oh, I see, it's not on auto. Ew, that turned out awful. Okay, let me adjust things a little bit. Okay, that's probably just about exactly the same, but we'll just go with it. So I've got an LED here. So I've got a diode coming from this positive rail here over let me use something better to point with. I've got this diode, and it's plugged into this red positive rail. It comes over, and then it's plugged into this row right here. And then I have this little LED plugged into there, and then it's also plugged into right there. And this row is the row where this resistor is plugged into, and then this goes to the negative, and that creates a full circuit right there. But yeah, so let's measure some voltages. So first off, let's just measure what our supply voltage is with our multimeter. So say that I don't know what this voltage range is at all. I have no idea what it's going to be, really, and I mean absolutely none. Well, with the exception of I know it's going to be less than 300 volts. We'll go with that. If you don't know at least that it's not going to be 300 volts, then learn more about what it is you're about to plug into, okay? Let's say that I think, well, it could be up to 300 volts, but definitely not more than that. I would switch this to my 300 volt range. Then I would take in my probes, and then I would probe the lines. And I'm going to probe these connection points here that I'm using to connect to the board. And you can see it shows 2 on there. It's like it thinks, oh, it's super low. It's like 2 volts. And that gives us really horrible clarity. Not only that is, if you measure a really low voltage on using a very, very high voltage range, it can be very inaccurate because barely any current or voltage is getting to the device that measures the voltage. So we say, well, 2 volts, well, then we're for sure should be good on our 20 volts maximum range. And now we can measure and we'll get some better clarity on our measurement. And we can see that it says it's 3.17 volts. And that's perfect because that's in the right range, and it's a higher voltage than 2 volts, so we didn't go over our thing. Now, if we did go over it, say that we're putting in more volts than 2 volts, but we don't know that yet, we would get an OL listed on our multimeter. And that's just saying overload. You know, it's taking in too much of a voltage. So we've now successfully measured that voltage. We can also use this to measure to see how much voltage is dropping over a specific component. So say that we had our circuit here. Just ignore this over here for now. That's for a different demonstration I'll show in a second. But we've got our circuit here and everything's the same pretty much, except this LED isn't lighting. Well, there's a couple things we can do to test this, but for the sake of this, we're going to say that our resistor doesn't have the correct value, and as a result, it's dropping too much of the power, and you're not actually ending up with the correct voltage. Or you can say that we'll say that this diode is dropping too much power before it reaches here for it to light this LED. We could use our voltage meter to see how much voltage was being dropped across this LED. So, I mean, across this diode. So, since this row is all connected, well, no, actually, I'll just do on either side of the legs, and we'll see that we're dropping just like 21 volts or 0.21 volts over that. So that's not too bad. And we can just kind of go down the line and see, well, what thing is using the voltage the most? And we say, okay, well, 6.20 or 62 or 2.62 volts is going to this LED, and that's good. Then we can just see, for instance, how much voltage is being dropped over this resistor, and that we do that an awful lot in electronic stuff because the amount of voltage dropped over this will depend on how much current is running through it. This is again something that you learn when you learn what Ohm's law. So, but that's a great example of some things that you would use voltage measurements for. Some things that are not so great for voltage measurement that a lot of people end up doing is measuring the voltage of a battery. Now, the reason why this isn't so useful is that batteries really need to be measured under load. But if you have a load on the battery, then you can get a much better understanding of its life. So like we can say for sure that this has 10 volts, that's a good battery. But there is a possibility that this has an issue inside the battery, and that as a result of that issue, even though the voltage is being outputted well, it can't actually the voltage might be very good, but uh, sorry, the voltage when it's not under load might be good, like this, like 10 volts. But as soon as it goes under load, it will end up the voltage will drop, and that's just how all batteries are always. It might not drop much, and that's probably the sign of a good, healthy battery, or a sign that you are using a battery that's way more heavy duty than what the need is. But just remember that if you're testing batteries, you always have to have some sort of load. And as a matter of fact, this particular cheap multimeter, bless its heart, has a battery test mode, and what it's doing is it is putting a resistor in series with this, or in parallel with these terminals, so that it is putting it under load. So like if we test this, you see we have 10 volts there. Let's change it to our 9-volt battery test mode and just see what it does. So now if we test it, it's 9.6 volts. And that's because the multimeter is acting as a little test load and it is dragging it down. So just keep in mind that if that voltage testing, you have to use voltage tests if you're going to test a battery, but testing a battery open without any kind of load means that you're going to be getting an improper result. So like if you're testing your car battery, for instance, just turn on your headlights um, and the brights and just see what your battery voltage is then. Because if your battery's bad, the voltage will be correct all the way up until it's under load, and then it will drop down quite a bit. So that's just a quick example of testing voltage in DC. If we're going to test voltage in AC, first off, don't test with a cheap meter like this, mains voltage, especially if you're inside a place like the UK, where your voltage is going to be 240 volts, because that can be dangerous. So AC voltage is a little bit different than DC in the sense that because the voltage and current is always going to alternate between positive and negative, it doesn't really matter which one you test, which way around you have your test leads if you're testing an AC voltage. That isn't to say that one of the things isn't hot and the other is not. It just means that in measuring voltage, it won't matter. But for instance, just to be clear, this is the hot on in the plug. So if you were to stick a spoon in or a knife in there, a spoon, if you were to stick a knife in there or some sort of probe in there and get touched when this will bite you. And this one is neutral, meaning it is essentially your 0-volt reference. And so that one won't. But either way, don't go poking around in sockets unless you're used to working on electrical equipment. Um, so to test this, I've got it in my 200 volt range because I know that my mains voltage is going to be less than 200 volts. And then I plug it in there. And you see it's 119.2 volts. We could have also stuck it in 300 volt mode on AC and gotten a similar result, but you'll notice that 300 volt mode doesn't have a decimal place anymore. So we don't get the 0.2 volts, we just get the 19. Not too big, not too important in our case, but you know, there it is. So that's testing AC voltage. Here, one second, let me get a drink. All right. So now that we've tested AC and DC voltage, do you know that they kind of test the same in a circuit? So like say that you were working on an AC circuit, you could still do the same sort of things. You could measure AC voltage drops and stuff like that. So, but most of the time you won't do that unless you're working on stuff like vacuum tubes and that, in which case I would hope that you are good enough that and experienced enough that you wouldn't be needing to watch this tutorial. Those vacuum tube stuff is very dangerous, very high voltages. So, same thing with AC. We won't go into why AC is dangerous versus DC, but just know that most of the time as a hobbyist you shouldn't be working in AC. Figure a way to not use AC on a project. Okay? All right. So now that we've spoken about voltage, let's talk about amperage. Now, amperage is probably the most improperly tested thing in electronics. And what I mean by that is every other thing that you're testing in some way relates to voltage. And as a result, you're going to be used to testing things like this. I've got my power source. Let's test the voltage. And if you're doing that and you're doing it but you're trying to test amperage, then you will have messed up because when you test amperage, you're not supposed to put your probes like this across your power source. You're supposed to put them in line with your load, like an LED, or a light bulb. So if you put your meter in amps mode, I'm going to put it into to an amperage up to um, 200 millivolts for this. This is now turned into a dead short. So what I mean by that is that this wire comes over and goes into the multimeter, and then inside the multimeter there's another wire that connects this port to this port, and then it now then comes up over here. What we're doing when we're measuring, and again this comes down to voltage, but what we're doing when we're measuring amperage is we have a very, very low value resistor that normally comes in the form of a piece of thick copper wire with a little kink in it. We have a very low value resistor, and and that is creating a short between these two things, and then we're measuring the voltage dropping across that resistor, just like we did in our little demonstration with this. And as a result of that, and then some fancy math, not even fancy, just Ohm's law, we'll then know how many amps are going through the circuit. But if you put this into something like an AC, like a wall socket, and on amps range, and you're using a cheap meter like this, it's going to explode. It's going to blow up the meter. It's at least going to, like this particular meter has a fuse. If you get a meter, it needs a fuse always. But it's going to either blow up your multimeter or your leads, or it's going to electrocute you. It's going to cause fire, and the fire is going to be plasma, and it's going to conduct electricity, and you're going to get burnt and electrocuted at the same time. Let that sink in. If you measure amperage like you would volts. So definitely make sure that you're measuring amperage correctly. So let's use this as an example. I've got my meter in DC amperage mode to 200 milliamps. Since I'm doing a low power circuit, I'm going to have it in the low power socket. So you'll notice that we've got a 10 amp socket here. It's got its own separate range, and we're not going to touch that for now. So we're just going to do low amperage mode, and this supports a thing up to 200 milliamps. I'm going to bring in my meter. Now, my test circuit again. Now, I don't know how much power this is using yet. So, like with the voltage, I'm going to shoot high, and I'm going to go, I think I know it's going to take less than 200 milliamps, but I don't know how much less. It could be in microamps, it could be in whatever. So now I'm going to take my meter, or my probes, and I'm going to disconnect the positive from my circuit. And you can do this from the negative or the positive, but the point is that you want to disconnect, is that you want your meter in series. You don't want it across the power source. So now I'm going to take my red probe here, and I'm going to touch it to this power source here. And then I'm going to touch the black leg to the beginning of the circuit. So now I've just taken and then added in an extra length of wire that runs through my multimeter. So now if I press this, you'll see that things light up. And I'm getting a reading on my multimeter that says 3.2 for 3.2 amps, or milliamps. And if I wanted more resolution, because that's less than 20 milliamps, I could change my range to 20 milliamps and then try this again. So I've got the positive lead for my test circuit to the positive lead of my multimeter. Then I'm going to take the black one and then stick it at the start of my circuit again. So now it says we've got 3.07 milliamps is how much this circuit draws. And now I know how many milliamps my circuit draws. Um, a note on this, you'll notice that there is no amp range for the AC volts on, or for AC or alternating current on here. It just has a little dash with the three dots underneath it for direct current. That's just because it's a cheap meter, and on a lot of small hobbyist meters they don't even do it, and I think it just has to do with it involves more room to create safe. You have to create better safety clearances and stuff inside the multimeter, and you just need to assume that anybody that's going to be using a meter of this caliber to test amperage from an AC circuit, which is almost always a higher voltage circuit, or a higher amperage, higher voltage circuit, that if a hobbyist was doing that, that they're going to end up killing themselves. So keep that in mind, that a lot of cheaper meters don't have it, and that most of the time you don't need to do that. Your AC will be rectified into DC, then it'll be safer most of the time, and then you can measure the amperage from between the rectifier and the rest of the circuit in your circuit, okay? Um, Next part about this is that the 10 amp range works exactly the same way as the other range. Except you will move your red lead from the milliamps range up to your 10 amp range. And when you do that, you're really creating a very, very high amperage a high amperage capability path through your multimeter. So if you do that, if you do that, do so at your own risk, and if only if you know what you're doing. The next part about this is that if you ever go over to your 10 amp range for any reason, and then you turn off your multimeter, and then you say, I need to measure a voltage, let's go over to voltage and try to measure it, you're going to short out your circuit. And I'm actually going to do that purposely here. My meter, or the power supply going to this, is a current limited supply, so I can do this without blowing the fuse in my meter, and I know that, but you'll see what I mean. So say I'm like, okay, I want to measure the voltage on my test circuit, so I've switched over to the test stuff, but I'm still in this mode. I'm not going to get a voltage. I'm going to measure, it's going to short out my circuit, and now if I've done this at a spot out here or something like this, I've blown parts of my circuitry right up. So, and if it's a high power circuit, I've probably injured myself too. So always, if you ever go into the 10 amp range, always make sure that you take it and put it back as soon as you're done using it. Additionally, if you ever use 10 amp range, do so for a brief period, a small moment of time, less than 10 seconds. Okay, um, or at least read your multimeters documentation. Most multimeters will say it can measure up to 10 amps for X number of seconds, and if you do that over that, then you will heat up components in your multimeter. Your multimeter will die, and either your path to your circuit is going to close, like your current source is going to be messed up on your circuit, or it'll blow up, or just keep that in mind. So now that we know how to test amperage, let's just go to continuity test mode. Now continuity test mode is pretty much the one, I mean, it's right up there with voltage as far as what you're going to be doing for troubleshooting. It's going to tell you how to do a great many things, and it's gonna show you. You're going to be like, well, am I getting a connection from one point of my circuit to the other? Um, is basically what a continuity tester will do. It'll tell you if you have continuity all throughout your circuit. When you do have continuity, I don't know if you can hear this, but it beeps and it'll display a very low value, most of the time 0. But if your leads have some resistance to them, which they will, you might see that there'll be a small drop there, right? Um, but what you can do with continuity mode is you can say, well, half my circuit is lit up and the other half isn't, or half the power circuit is getting half of my circuit is getting power and the other half isn't. So they should all be powered from the same rail. Am I getting continuity? Am I getting continuity between the points? So like in this case, I could say, yeah, okay, I'm getting continuity through the entire circuit. Oh, let me zoom out, guys. Sorry about that. Okay, but yeah, you can say, well, I want to make sure that we'll say that this circuit here will simulate a broken component, right? Well, so we'll just take this diode and we've taken it out of this power bus, or light is off, and we say, well, this diode should be getting power. Does it have a connection? So you can just test the connection, and you say it's not getting a connection, and that's the problem. That's a really basic way of using continuity mode, and it's the one that you'll probably use the most of the time. But there's another way that you can use continuity mode that will help you in real-world applications a lot, which is that sometimes your circuit will develop a short. Why didn't that light up? Sorry, right. So the other thing though is that sometimes your circuit will develop a short. Say that you've got a capacitor in there, or we'll just say a little like a resistor or something. Let me grab a capacitor because this is the one that's most common that you'll run into. So this is a capacitor here. Sometimes these become short circuit, and suddenly you will no longer have power to your circuit. You'll see that you'll do your amp test and you'll see it's drawing amps, and you'll do your voltage test and it'll show that the voltage has gone way down, and that'll mean that you have a short probably. So um, we'll simulate that short by taking a jumper wire and jumping from the positive, from the positive like this to the, oh, actually, let me put this back up on the box so you guys can see what I'm doing. All right, so we'll simulate a short by taking a jumper wire and going from positive to negative. And now our circuit's all turned off. So, and we say, well, we can see because of because we've done an amperage test that we're drawing amps. So we are doing, it is taking power, but nothing's on. Why could that be? Well, this capacitor could have gone short circuit. And if it did go short circuit, then we should have continuity between the positive and the negative that we wouldn't normally expect. So I'll just take this. It doesn't matter which whether we're using positive or negative in this case, but I touch it and I can see that with my continuity test that's a really low number. I wouldn't expect that low of a number on the thing. I was actually surprised, and it just has to do with the other circuitry though, that I'm not getting a higher number like that. This lead must be, okay, there we go. It just wasn't making a good connection there. But you see it's beeping at me, and it has a really low resistance value. If we get rid of this short and try this test over again, you'll see that it doesn't even register. It says OL for overload, because there isn't a direct path between the positive and the negative. If we use continuity test and then discover that we do in fact have a short, like we did here, then we will see a very low resistance value if your breadboard you're working with isn't a pile of shit like mine is. But yeah, so that's kind of what you'll see, and that'll help you determine that the reason why your circuit isn't working is because of a short. All right, so now let's take a look at diode testing mode. So um, your multimeter is probably going to either display um, diode testing mode as either the voltage drop across the diodes, or actually it's basically the forward conducting voltage of a diode. It'll actually display that in either volts or millivolts depending on your multimeter. Most nicer multimeters will display it in volts, or if it goes into millivolts, it'll be like 0 point something something volts. It'll display it that way. This particular multimeter displays it as millivolts, and basically it's on the same as the continuity test mode here. A lot of multimeters do join the things together, so they'll beep in diode test mode, but a lot of them actually do have a separate continuity test mode versus a diode test mode, and they won't beep. They'll also, I forgot to mention this in continuity test mode, but depending on your multimeter, it'll have a threshold on the voltage. I'm sorry, on the resistance before it'll beep. This particular multimeter I looked up and it said that it was 50 ohms is the threshold of where it'll beep. But anyways, so diodes, in case you're unfamiliar with what a diode is a diode allows electricity to flow in one direction. There is something called breakdown voltage where it'll conduct in both directions, but for our purposes, let's just say that it'll only allow things to conduct in a single direction. But in that but there is always a threshold point before it'll start conducting. On this particular diode, it looks like the threshold voltage is about 233 millivolts. So below that, it won't conduct. So you can also use diode test mode to test LEDs. I'm not sure if this is going to work for this. Most of them have less than 3 volts for the voltage, but we may, yeah, no, it's not going to conduct enough, but this is a blue LED, and it's pretty rare that you'll find a blue LED that conducts enough. Something that's interesting about this that I noticed is that the actually, no, it's not doing it now. Okay. I tried this a second ago, and then uh, the film, or the space ran out on my drive. So, but it was actually beeping on this like it was a low value resistor, but this is a 200 ohm resistor, and yeah, that's very strange. Anyways, but yeah, so this is how you just test the forward voltage, and it's good to use. You can use diode test mode when you're testing things like MOSFETs. You can also, but that's probably a separate topic we can do a different time. Also, it's good to be able to test to see if your diode has broken down and is able to conduct in the other direction. And you can see this just displays OL because we aren't be able to conduct in the opposite direction. So that's a good thing. other than that, we just kind of have capacitance left. So let's do capacitance real quick. For this one, we'll actually bring in the Klein multimeter here, and I'll let's see, I'll stick it like something like that. Yeah, that should work. So a lot of multimeters have capacitance test functions to them, and this can be useful sometimes in situations where you need to test to make sure that there will be enough capacitance on a capacitor like this one here. But the thing about capacitance mode on a multimeter is that most of the time capacitance, just measuring the capacitance of a capacitor isn't really sufficient for troubleshooting purposes most of the time. What I mean by that is that yes, we can measure that we can measure this and see that it's about 522 nanofarad. This is actually a 407 or 470 nanofarad or 0.47 microfarad capacitor, but we don't know if this has a high uh, ESR or equivalent series resistance on it. So that doesn't really bode well for our use of the multimeter of that function as a means of testing a circuit that's bad. What you really need is you need an LCR meter or an ESR meter. You can also test equivalent series resistance using an oscilloscope and a signal generator. I'll probably do a little quick video on that as well, but just know that that capacitance meter aspect of most multimeters is pretty bad, especially if you get into really low resistance. I'm sorry, low capacitance capacitors. Those have a really or multimeters have a really hard time with that, and it's just a hard thing to do correctly. They also sell these little kits for component testers, and I can say that these little guys are actually really good for testing. Let's get this autofocus off. Sorry about that. I didn't realize it had come back on. Also, let's zoom in just a little bit on this guy. But these are actually really good capacitance meters. You can even hook up some test leads to them and do some good things. But I'm sorry, I wasn't looking at the screen, and I didn't realize how bad that was. Let me bring this in and adjust some stuff. Sorry, let's do this over. We'll do. Can you see that? Okay, yeah, okay, good. All right. So let's do this again. So if we put in this little capacitor, and test, you'll see it says 498.4 nanofarad, but it says ESR, or equivalent series resistance, is about 7 ohms. Now, if we look at the larger capacitor, you'll see that it's got a 326 microfarad capacitor, but it's got an equivalent series resistance of 0.18 ohms. And that is great, but it's possible to have a capacitor that's going bad that will show an ESR of like 10 ohms, and that would be unacceptable in the circuit. So yeah, just keep that in mind, that you can use the capacitance meter on a multimeter, but it's just not going to be the same as if you had an ESR meter and an LCR meter. Um, an LCR meter is a meter designed to measure um, it inductance, capacitance, and then resistance with a high accuracy. So anyways, I think that just about does it for this video. It definitely has gone a lot longer than I had thought it would. So if you're still watching this, thanks for sticking with me there to the end, and I hope that this helped you guys out. And feel free to throw in any kind of corrections or comments or anything like that down in the comments, and I will talk to you guys later.